Welcome to the video tutorial of queue implementation using Python. Those who wants to implement queue data structure using Python language can go through this lecture and can try to implement the data structure. At first, I want to show some basics about queue. So queue follows the FIFO operations. So what does FIFO mean? FIFO means first input and first output. So according to FIFO operation, if any data structures, suppose an array contains some multiple values, so if I consider 1, 2, and 3, then the first element which will get removed is the element which was inserted first in on that designated data structure. So here our, as we see, first indexed value is 1. That means 1 was inserted firstly on that array. So according to FIFO operation, 1 will get removed first. So that's FIFO operation. Queue has three core methods, which are enqueue, it is used for inserting values in the queue, then dequeue, which removes value from the queue, and peek, it does not enter or remove any values from the queue. It is used for returning the top value of the queue, which is the firstly inserted value of the queue. Now we will see how they works. If we enqueue 1 in the queue, this is 1. So this will be known as top of the queue. Then again we enqueue 2 in the queue, so it will insert 2. If we peek value from this queue, then it will return 1 because 1 is the firstly inserted value in the queue. Now if we dequeue value from the queue, then it will work according to FIFO. What does that mean? That means it will remove 1 from the queue, and here top will get changed and it will be indicating 2 from now. If we peek again now, it will return 2 because 2 is the firstly inserted value now. Okay. If we again enqueue 3, enqueue 4, okay, then we dequeue, then 2 will get removed and our top will become 3. And now if we peek again, we will now get 3 because 3 is the most oldest value which was inserted in the queue. That's how enqueue, dequeue, and peek works. We can also use two variables named front and rear in order to make our implementation more flexible. So basically we use front for tracking the top element of the queue and rear for tracking the number of inputs and outputs. So if we see how they works, it will, at first we take a list or array named queue. So we initialize our front by 0 and rear by -1. Okay. So, so if we enqueue a value on the queue on this list, then suppose 2, rear will get increased by 1 and front will remain 0. So here front and rear both are in same index. Then if we again enqueue another value, so then rear will get increased by 1, front will remain static. Then again we enqueue another value, rear will get increased by 1, and front will not change. If we pick here, basically the front value of front index number of q will get returned. That means which is 2. That means front is containing the index of our top value of the queue. Okay, then if we dequeue, then our here also will value of this index will get removed, which is 2. Front is 0, so which is 2. It will get removed. If it will get removed, so here this index was 0, 1, 2, but now it will become 0 and 1. So here our rear will be get decreased, so it will become 1. So that's how front and rear works. Front basically indicates the beginning index of the list, and rear basically controls the last index of the list. Now we will see the implementation of queue using list. To do this, first we have to declare our queue class. So here we will declare a list named queue, which is an empty list. Then we will initialize our front variable, which is 0, because it will always indicate the first index of the list. And then we will declare rear, which will be initialized as -1. They are our global variables. Now we will define the necessary methods of the queue. So firstly, we will define the enqueue method. So the enqueue method, which has 2 parameters. One is self in order to access the global variables, and another is val. Here we will add values in the list. Now our rear will get increased. This is how our enqueue method will look like. Now we will define dequeue method. Here we will remove the first value of the queue, which means we will remove the value of beginning index. In order to store this value, we have to declare a temporary variable and store the value into it. Therefore, front indicates the value of the first index of the list. Actually, it indicates the first index of the list. Then we will do the operation of the removal. Basically, what we are doing here, we are keeping the values of, we are basically keeping the every values of the list, excluding the first value of the first index. So we are keeping the values from second index until last index of the list here. So we will now pass values from the second index to last index in the list. So how can we do this? So here self.front is indicating the first index. So self.front plus 1, which indicates the second index. So we are keeping the values from second index to last index. So which is our last? Our last index is rare here. Self.rare, because we are accessing the global variable. Now we will decrease our rare because we have removed one value. Now we will return the removed value. Now we will define the pick method. Basically, it will return the value of the first index of the list. So that's it. Our queue class is defined with its methods. Now we will test whether the queue works properly or not. So if we initialize the queue, we in queue, suppose we add this value to the queue. We check whether our pick method works properly or not. It is basically returning the top value of the queue, so we indicate it like that. If we run it, yes, it works properly. Here I have only one value in the queue and my peak is 1 here. Okay. Now we enqueue some more values in the queue. Basically, I can copy that. Okay. Now I can check whether my peak is working properly or not. Okay. Here my peak is working properly again. If I dequeue some value, dequeue a value from the queue. Okay, first I can print it. It is removing my values, so I can denote it. And now I will again check my peak. See, dequeue and peak and queue, three methods are working properly in this queue. So at the very first, our queue was value of queue was 1, our top was 1. Then we added 4 more values. Our top remained same because we did not remove any values. Then we removed the first value of the list or queue, which worked as FIFO, first input and first output. Then we called pick method. So we removed first value, which was 1. So now our top is 2. Then we called pick and it worked properly. So this is how we can implement queue using list in Python. You can try it by practicing it, and that's it.